states, as I said, so I'll accept that. That's a 3. 3 is common. The aluminum group. Those are the ions. Now I said when you mix up the known, you don't have to, just to speed things up. This is the one that causes problems a lot. And this one you don't have to have in the known because the color disappears by the time you need to use it as a reference. So you just, if you want to, you can actually do the generation of the permanganate ion simultaneously with doing the unknown. This one, you're just going to do the calculations for the nickel, put it into a test tube, and add your dimethylglyoxine because the reaction to test for nickel is very ion specific. Dimethylglyoxine makes a red precipitate with nickel ion. It makes a reddish color solution with iron, but that's not a precipitate. So it's very easy to do that. This is called a selective precipitant. And notice, if we had lots of money, we could find different reagents that each of which would only precipitate one of the ions that we're studying. So we buy all these expensive reagents, we put a drop of unknown in each of 26 test tubes, we add a drop of reagent to each one and see which ones make the precipitate. I guess we have to do 26 by 26 test tubes to see which one makes the precipitate, and then you've identified everything you need to identify for this test. It can be done, we can do that spectroscopically, but that's a different course. So what we're doing here is separating by precipitation. Okay? I talked about the pitfalls of the procedure 1015A. 1 I called it because you're adding ammonia till the solution is basic. Then you're adding ammonium sulfide. The biggest problem is you make a colloidal suspension. It's hard to get that to precipitate. The only thing you do to make a colloidal suspension precipitate out is you heat it. You add things like concentrated ammonium acetate. That's why our ammonium acetate is so concentrated, so it's more effective in causing the precipitate to coagulate in this procedure 15. And the other thing that causes colloidal suspensions to settle out is time. If you make the precipitate on a Wednesday and put it in your locker, when you come back on the following Monday, chances are most of it has settled to the bottom of the test tube. Okay. But lots of times we want to get that done and move on to the next part. The next part being, I was going to do one net ionic equation for you. I didn't do it because I just talked about that this morning. But nickel, for instance, and I'm going to make a sulfide out of that. The precipitate, and here's my principal species. That's what I was talking about this morning for your net ionic equations with the ammonium sulfide part of the precipitate. You're going to make, that's your black precipitate. You have an extra hydrogen ion, and the rest of it just sits there as manganese, which doesn't form a complex ion, is even easier because Mn2 plus HS minus gives MnS plus, and I guess you have to have some ammonia because it's a basic solution, because you can't get an H plus in the basic solution. Basic solution of ammonia when you're doing this, the 1 drop extra. Okay. So all I'm trying to point out to you is the equations are fairly simple for the sulfide precipitation. Then we go to, and I'm going to stop after this. Work, get there. Procedure 16 is where you separate the A and the B groups. And here we're forming a bunch of complex ions again. Adding 10 drops of 12 molar HCl. In principle, everything should dissolve. Unfortunately, it doesn't. Unless it might be your unknown. You don't have this sulfide or the nickel sulfide. Most of the stuff dissolves in HCl. So this is procedure 16. And it says boil for 30 seconds here somewhere. And for some of the unknowns, it means 30 minutes. Okay? So just put a big question mark over the 30 seconds. If you have something like manganese sulfide or zinc sulfide is even better. But this will also dissolve in a similar fashion. You have something like this, very simple equation. So these things dissolve easily at 12 molar HCl. And if that's all you had in your unknown, it might only take 30 seconds. Okay? But if you start having this sulfide or the nickel 2 sulfide, you're going to have to switch to, it doesn't dissolve, and your unknown won't, your known won't, but your unknown might. We're going to use what? Your aquaregia mixture again. And you replenish it till everything dissolves. The only thing that won't dissolve, you may get some yellow sulfur. Which you don't say. That's what that means. Okay. It says add 3 drops if it doesn't dissolve. Chances are you can count. Except when you're doing the unknown, your unknown might dissolve in 12 molar HCl, which makes life easier. But eventually you may have to add the aquaregia mixture. It says add water, transfer to the test tube, remove any precipitated sulfur, that's what I just said, decant into a casserole, note the color of the solution. Then it says make it really basic or strongly alkaline, 8 molar sodium hydroxide. So what we have here, notice if you use aquaregia, you're going to have a lot more of this than this. You could even get the cobalt 3 plus. So you probably aren't going to bring this up to permanganate state yet, but you'll have aluminum, chromium, and zinc. Now here's the separation step. You're adding NaOH. The decantate contains in other words, way back in procedure 6, when you separated the A and B groups, you had different proportions of the sulfide ion, trithio, tetrathio, etc. Here they're all going to be tetrahydroxos. Okay? So this is what's in the solution phase. The precipitate phase back here, that's still a greenish color. This is the red-brown color. Cobalt 3. Nickel. And which one did I miss? Manganese. So these are all the precipitates in there, and it's just a simple reaction between the hydroxide ion to make the precipitates. So that's the separation. The next thing you want to do, and I think you have cobalt 2 hydroxide also. The next thing you want to do while it's in the casserole is add, and this is 16A, I guess, 16B, hydrogen peroxide. This is the important step right here. The hydrogen peroxide is in there. To convert the tetrahydroxochromate 6, I'm sorry, that's chromate 3, to chromate ion where you increase the oxidation state of chromium to +6. This is a yellow-green. This is the yellow color you saw with chromate when you used it as a precipitated reagent. So you're looking for that color change from yellow to green, yellow-green to yellow. These don't get changed, but the thing that influences that is that it changes this to black, and it changes this, I guess it does start as 2. It changes this one to black also. BLACK. This is the cobalt 3 hydroxide. So both of these are black, and you're trying to look for the color change of the solution from yellow to green, whereas everything's turning black from these two things. If the cobalt and manganese aren't there, this is a much more apparent thing. One of the things you can do when you're doing your test is actually take some solution out of the casserole, put it in, he doesn't say this in the notes, put it into a test tube centrifuge. Look at the supernatant liquid. Where you're known, if it looks yellow-green, you add another drop of hydrogen peroxide, you should see it turn yellow. That means you need some more hydrogen peroxide in the casserole. The thing you don't want to do is add too much of an excess of hydrogen peroxide. At the end, you're supposed to boil it to decompose the hydrogen peroxide. But if you don't decompose the hydrogen peroxide, when you're doing the manganese test later on, it will prevent you from seeing the permanganate color, because hydrogen peroxide is very effective at breaking down the manganese, permanganate, into manganese ion. In fact, a couple of people, when they got stains from the permanganate on their fingers, asked what to do about it. And I said, you can put some hydrogen peroxide on it, but we don't give you the hydrogen peroxide here. You have to go home and use your medicine cabinet or whatever, because the ones we have here are much stronger. Not only take away the manganate color from your fingers, it'll take away some of the skin, and you don't really want that. Permanganate